Okay, guys, this is part 2 of our review. Let's jump in back where we left off. We were on number 13. So we're trying to find the exact value. It's obvious that this is going to be a half angle because of that 0.5. So our half angle, theta over 2, is equal to 67.5. In order to find our whole angle, just theta, we need to multiply by 2, which will give us 135 degrees. Okay, so half angle, and this is tangent. I'm going to take a look at our list of identities. And for our half angles, tangent actually has 3 different options to choose from. They have their advantages and disadvantages. Like this one has a giant square root. The other ones don't have square root, but you would have to know cosine and sine. So it's kind of whichever you want to pick. There is no wrong answer. Pick whichever one you want. I am going to use this one in the middle just for fun. 1 minus cosine over sine. That was our identity. So we are going to fill in theta with 135. So 1 minus cosine 135 over sine 135. Those are values that we can find from our unit circle. So here's 135. Sorry, let's move that. Cosine is negative square root of 2 over 2, and sine is positive square root of 2 over 2. So we have 1 minus negative square root of 2 over 2 over positive square root of 2 over 2. So the most obvious thing that we need to change is that minus negative. That's going to turn to a plus sign. But the other thing that I want to change is there's fractions in here, and I don't want that. So since they both have a denominator of 2, I'm going to multiply the entire fraction by 2 over 2. So we would get, so 2 times 1 is 2. Two times square root of 2 over 2 would just be square root of 2. But remember, minus and negative means that this is going to be plus. And then at the bottom, 2 times that fraction is going to be square root of 2. But this brings us to a new problem. We're not allowed to have that square root at the bottom, remember? So we are going to rationalize this by multiplying by square root of 2 over square root of 2. So same thing. That needs to get distributed to both things in the numerator. So that would give us 2 square root 2 plus 2. And in the denominator, just 2. So one last thing to simplify is each one of these is its own fraction. So if I actually divide here, that's going to be square root of 2. And then over here, 2 over 2 is 1. So that is our final answer. Okay, next one. So see how mine is in radians? On your paper, I went ahead and I changed it to degrees because the ones on the test are degrees anyway. So I didn't want to do a problem that was too hard. So the same value in degrees is 105. Okay, so now it matches yours. So this one, it's not obvious that it's a half angle because, I mean, there's no 0.5. But the reason why it's a half angle is because 105 is not on the unit circle. So if half is 105, if we multiply by 2, the whole angle is 210, and that is on the unit circle. So half angle of cosine, let's look at what our identities say to do. Okay, so half angle, there's only one rule for cosine. So that's plus or minus square root 1 plus cosine theta over 2. So I'm going to write that down before I forget. Plus or minus 1 plus cosine theta over 2, and all of that was in the square root. Okay, so let's fill that in. Instead of theta, we're going to put in our 210. 210 is on our unit circle. Instead of going to the top to show you, I'm going to go ahead and just write what it is. I know that it's negative square root of 3 over 2. So same issue that happened from before. So sorry, this was supposed to be a plus. When you have plus a negative number, it might as well just be minus. So we can change it to a minus. But then also, I don't want to have this 2 as a denominator. So I'm going to multiply by 2 over 2. And that gives me 2 minus square root of 3 over 4 underneath the square root, and it's still plus or minus. So now looking closely at it, I don't see anything else that I can simplify. The only issue now, so one last thing, is that it has to be either plus or minus. It can't be both. So how do we decide? Well, 105, that is in quadrant 2, and cosine is negative, so negative in quadrant 2. So that's what tells me that I need to have a negative out here. Okay, let's move on. Okay, still some more half angles. I know that because what we're trying to find is beta over 2. So this is actually similar to the one that we just did because it's cosine again. So I still remember the identity. It is, so cosine of beta over 2 would be plus or minus giant square root 1 plus cosine beta over 2. So in order to use this identity, we need to know what cosine beta is, and the only thing that they gave us was tangent beta. I know that tangent is y over x. So we can find r by using our Pythagorean theorem. 5 squared plus square root of 11 squared equals r squared. 25, 11, and that makes 36, which is perfect because that's a perfect square. R is 6. So we need to find cosine. Cosine is x over r, so filling that in would just be 5 over 6. Now, it could be plus or minus. Remember, anytime you take a square root, plus or minus. But according to this piece of information, beta, whatever our angle is, oh, I used theta. I should have changed this to beta. Let me fix that. Okay, so that is somewhere in between 3 pi over 2 and 2 pi. So that is quadrant 4, Q4. And in quadrant 4, cosine is positive. So you could just leave it the way it is. I'm going to write a little plus sign so I remember positive. Okay, so now I have what I need to plug into that identity. Plus or minus square root of 1 plus 5 over 6 and then over 2. So just like before, anytime I have a fraction within another fraction, I'm going to multiply by whatever the denominator is. So I'm going to multiply by 6 over 6. So then that would be plus or minus square root of 6 plus 5 over 12. Now 6 plus 5 is 11. So now I'm up to this point. You always want to simplify as much as you possibly can. So you can think of this as separate. So square root of 11 over square root 12. Now the square root of 11 is just going to stay the way it is. But 12, I can simplify that to 2 square roots of 3. Then we have the problem of a square root at the bottom. So to rationalize, we would do this. Square root of 33 over 6. That is our final answer. So I know it's a lot of simplifying, a lot of rationalizing. Okay, let's try another half angle. So similar to that one. This time it's tangent. So if you remember before, tangent of a half angle has 3 different options to choose from. So let's take a look at what those options are. So half angle, those are our 3. You could use any one of them that you want. No matter which one you pick, you are going to get the same answer. But just like before, I kind of don't like doing the one with the square root. I usually try to stick to one of these two. So you need to have cosine and you need to have sine for whichever one of those that you pick. I'm going to use the same one as I did before. I like this one. So 1 minus cosine over sine. One minus cosine. Oh, they're using x's. Over sine. So I have cosine already, but we need to find sine. Cosine is x over r. So we're going to use the Pythagorean theorem to find y. So 2 square root of 6 squared plus y squared equals 5 squared. This is 24. That's 25. So y squared has to equal 1. The square root of 1 is still just 1. So sine is always y over r. So sine is going to be 1/5. And in quadrant 3, sine is negative. I know we're in quadrant 3 because I'm just reading this part. So now I'm going to fill into this. 1 minus, cosine was negative, so I'm going to go ahead and change it to the plus already. And then over negative 1/5. There is 5s in 2 places, so let's just multiply by 5 over 5. And that will be 5 plus 2 square root 6 over negative 1. And so actually, we're basically done. When you divide by a negative, it's just going to change the signs of everything. So negative 5 minus 2 square root of 6. And that's it. We're done. Okay, so let's move on to the next type. These were product sum identities. So this is the last of what we did. So for the first two, 17 and 18, we're just going to rewrite them. Right now, it's a product because it is being multiplied. So if we're rewriting it, they want us to change it into either a sum or a difference. So product first to sum. And this is sine times sine. So when we look at our identities, product to sum, sine times sine. So we are going to follow this format. 1/2 cosine A minus B minus cosine A plus B. Okay. So 1/2 bracket cosine of A minus B minus cosine of A plus B. Okay, so if we do that math, 7 minus 5 is 2, and 7 plus 5 is 12. And so last thing to do is to distribute the 1/2. So 1/2 cosine of 2x minus 1/2 cosine of 12x. Okay, let's try our next one. So again, it's a product because of that dot in the middle. We want to change it to either adding or subtracting. So cosine times sine. I'm going to take a look at our identities. That would be this last one, cosine times sine. And that is sine of A plus B minus sine of A minus B. Okay, so this one's a little bit unique in that it has this -8 out front. So that still needs to be there. But we're going to times it by what the identity said to do. So 1/2 sine of 2a plus 6a, and then minus sine of 2a minus 6a. Okay, so -8 times 1/2 is -4. So I'm going to go ahead and replace that already. Then let's simplify what's in those parentheses. 2 plus 6 is 8a. And then 2 minus 6 is -4a. Then this here is going to cause us an issue. Anytime you have a negative in here, you want to use your even odd identities to simplify that out. So I'm just going to write a side note here, even odd identity. When sine has a negative, you can move it to the front of that term only. So minus this negative is going to move out here. Negative sine of positive 4a. But now that double negative changes to a plus sign. Okay, and then last step is to distribute the -4 to both terms here. So we would have -4 sine of 8a minus 4 sine of 4a. That is our final rewritten expression. Okay, for the next one, it says to rewrite each expression as a product. So right now it has a minus sign and a minus sign. We want to write it to where it's multiplication. So a sum to product. This is cosine minus cosine. Let's look at our identities. Okay, so sum to product. Cosine minus cosine is this last one. So this is the only one that starts with -2, and then sine of a plus b over 2, and then sine of a minus b over 2. Okay. Okay, so starting with the -2, sine of adding the two angles, so 2 theta plus 10 theta all over 2, and then times sine of now subtracting them, 2 theta minus 10 theta over 2. So this would be -2 sine of 12 theta over 2 times -8 theta over 2. Let's do the dividing by 2, so it'd be 6 theta sine -4 theta. This is the same issue from before. Anytime you have a negative sign, you want to use your even odd identities. And with sine, that negative is going to go in front of the term. Only remember we're multiplying, so instead of moving it in the middle, we can move it all the way out front. So this is going to be -2 sine 6 theta sine 4 theta. And since there's double negative, it turns to a positive. So really, it's just 2 sine 6 theta sine 4 theta. It's positive, so we don't need a symbol in the front. Okay, our next one. So you always want it to just be the trigonometric terms. This one has coefficients in front, so that's the first thing you want to get rid of. They both have -5, so let's divide them both by -5. So that would be when I divide by -5, negative divided by negative makes this positive. Okay, so I have sine plus sine. I'm going to look at my identities to see what I'm supposed to do here. And when you have sine plus sine, that's this first one, it's 2 sine adding the angles and then cosine subtracting. So I still need this -5, but the rest of it's going to be 2 sine 3y plus y over 2 cosine of 3y minus y over 2. Now -5 times 2, these coefficients, that's -10. So sine of 4y over 2, cosine of 2y over 2, and then one last step. 4y divided by 2 is 2y, and 2y divided by 2 is just 1y. Okay, almost done. 2 more problems. Now I want to find exact values. So there is one of each. So this first one, it is subtraction, but see how these radians both have 12 at the bottom? I know for a fact that that's not going to be on the unit circle. So this one, we are going to have to change it into a product. So this 4 is still going to be there, but I know that I can change the rest of it. Sine minus sine. Here we go. Sine minus sine is this one here. So we're going to follow this format. Okay, so there needs to be a 2. And then cosine of adding those two angles. So it's going to get a little complicated for a second. 19 pi over 12 plus pi over 12, then over 2. Okay, and then times sine of subtracting those two angles. So 19 pi over 12 minus pi over 12 divided by 2. Okay, so let's simplify what is inside those parentheses. Well, 4 times 2 is 8. Cosine. So everything in this parentheses here. I know that the numerator is going to be 20 over 12. I'm going to write this as a side note here on the top. But then if I'm dividing by 2, that's the same as multiplying by a half, which gives me 20 pi over 24. When you simplify that as much as you can, it gives you 5 pi over 6. Now we're going to do the same thing for the other set of parentheses here. 19 minus 1 would give us 18 pi over 12, but we're going to multiply by a half, which is us 18 pi over 24. And when you simplify that down as much as you can, that becomes 3 pi over 4. Okay, so each of those has its own exact value. So cosine of 5 pi over 6, let's look at our unit circle. So here's 5 pi over 6. Cosine is negative square root of 3 over 2. We also need to know what the sine of 3 pi over 4 is, so here's that. Sine is positive square root of 2 over 2. So we're going to fill those in. So negative square root 3 over 2 times positive square root 2 over 2. Remember that 8, all whole numbers, are over invisible 1. So when you're multiplying this, you just got to multiply all of the numerators. That gives me negative 8 square root 6. And then multiply all the denominators, which is 4. And as you can see, there's something to simplify here. 8 divided by 4 is 2. So this will become negative 2 square root 6. Okay, and then last problem. We want to find the exact value, but same issue. Anytime you have radians with 12 at the bottom, something has to change because I know that's not going to be on the unit circle. So let's change this into a sum or a difference. So product to sum. I know the identity when you have cosine times cosine is to subtract and then to add. So it'll be 1/2 cosine. Let's subtract those angles. So 11 pi over 12 minus pi over 12 plus cosine of adding those angles. Okay, so that first set of parentheses, 11 minus pi, that's going to be 10 pi over 12, but we're going to simplify that as much as we can So it's going to turn into a 5 pi over 6 plus cosine. Same thing here. 11 plus 1 is going to give us 12. So 12 pi over 12 is just pi. So now we find the exact value of each. We just did cosine of 5 pi over 6, so I remember that it's square root of 3 over 2. And then we need cosine of pi, which is right here. So here's pi. Cosine is -1. So I want to add these two fractions here, but in order to do that, they need to have the same denominator. So that 1, I'm going to change it to 2 over 2. Also, it's plus negative, so I might as well just be a minus. So you can put that together and just make it be square root of 3 minus 2 over 2. But now multiplying by 1/2, it's going to turn into negative square root of 3 minus 2, now over 4. Because that 1 gets distributed to both things, this 2 got distributed. So this is our final answer. Okay, and then that is it for this review. Remember, we're going to have our test over all of this stuff tomorrow.